Today I would like to tell you about temporal intuitionistic sets. We would like to define and analyze them. This is our own concept, my own concept. However, it is clear that it's based on the idea of intuitionistic sets. They were introduced by Çoker from Turkey in 1996, and perhaps you know that they can be considered as a crisp version of intuitionistic fuzzy sets studied earlier by Atanassov. And as you know, nowadays there are many papers on both intuitionistic sets and in particular on intuitionistic topological spaces. And in fact, even on this channel I reviewed some of these papers. Moreover, temporal fuzzy sets and temporal intuitionistic fuzzy sets have been investigated by some authors too, so look to the bibliography of our video. Well, now what about temporal intuitionistic but not fuzzy sets? Assume that we have some non-empty set capital T. We say that T is a proper time set or just a time set that is used to model the course of time, if and only if T is a well-ordered set contained in the set of positive real numbers, together maybe with 0. For convenience, as you can see, we shall just say time set. And then any indexed family of intuitionistic sets on X, indexed with T from capital T, is called temporal intuitionistic set on X and denoted just by AT, for example. So it is clear that for any particular moment, this, I would say, S moment realization of our temporal intuitionistic set is just some intuitionistic set consisting, as always, of two counterparts. Left counterpart is so-called truth set and the right one is falsity set, and their intersection is empty. We assume tacitly here that the reader is already familiar with the idea of intuitionistic sets. As for the complement of our temporal set, it's defined as an indexed family. We can use this symbol C or just minus AT, where for each element we have that the order of truth set and falsity set was reversed, they were replaced. And this is again taken from the theory of Çoker and his intuitionistic sets. Universal temporal intuitionistic set is the one that for any moment we have universal intuitionistic set, so X and empty set, while empty temporal intuitionistic set is just an indexed family where for any T we have empty X, so intuitionistic empty set. Okay. So these things are clear. Some examples of temporal intuitionistic sets on various universes. You can analyze them. They are rather simple. For example, we have finite universe consisting of ABC, and our time set is the set of natural numbers. And there is some pattern. You can analyze this pattern, how it goes. Or alternatively, you have the set of rationals here, and T is the set of even natural numbers. So we define our temporal intuitionistic set only for 2, 4, 6, 8 and so on. Well, say positive and even natural numbers. And now the pattern is that the end set consists of the left counterpart, which is 1/2, 1/4 and so on till we obtain 1 over n, while the right counterpart is minus 1/2, minus 1/4 and so on, and finally we get minus 1 over n. Clearly, both counterparts for any n are, have empty intersection. As for the algebraic operations on our sets, well, there are some problems. They are similar to those problems that can be associated with soft sets. The easiest way is to define them in the following manner: that to assume that all temporal intuitionistic sets on a given universe X, that they are defined for the same maximal possible time set. Well, namely this one. But you could say that maybe you want to omit some moments, to say that you do not want to associate them with any set. well, here the idea is that we just assign intuitionistic empty set to each moment of this kind. It's a kind of simplification. This is visible in the next example. Assume that we have real line as our universe, and our time set is, well, our set odd is the set of odd natural numbers. And for any odd natural number, any odd moment, A1, A3, A5, and so on, we define our intuitionistic sets in the following manner. And so on. You can easily check. And now we obtain our intuitionistic temporal set, and we assume tacitly that for any t that is not an odd natural number, AT is just empty set. So for example, the moment 2, the moment pi, they all get the same value, namely empty set that is an ordered pair empty, comma x. Okay, so in some sense AT now is defined only for this time set odd, or from the other point of view it's defined for the whole t, but with this assumption that was described here. If we have this assumption, then it's very easy to define union of two temporal intuitionistic sets. It's just like intuitionistic union for each moment, and intersection. It is just like, as you know, intuitionistic intersection for each moment. Perhaps it's easy to prove that temporal intuitionistic sets with these operations form De Morgan algebra. Some special classes, cycles. It is possible, here you have formal definition, yes, it is possible that some pattern repeats in our indexed family or in our sequence, as in this case. We have universe consisting of positive natural numbers, and our time set is identical. And let us define our temporal intuitionistic set in the following manner. Note that for A3, you get the same thing that for A5. For A6, you get the same thing that for A4. Then for A7 is like A3, for A8 is A4, and for any I bigger than 9, greater than or equal to 9, you get empty set, intuitionistic empty set. So you have finite cycle of a signature 3, because it starts at the moment 3, 2, because its length, its step is 2, because A5 is like A3, so 5 minus 3 is 2, and the same with 6 minus 4. And the third component of the signature is again 2, because we have 2 repetitions of this pattern, yes? Only 2. This concept can be generalized, and this is in our paper, which is prepared now. So this presentation contains only several fragments of this paper, like for example the idea of time consistent sets. Here you have an example, you can analyze it later. The idea is that imagine that you have a temporal intuitionistic set which has some very strong property, namely that for each maybe different 2 time moments, the following holds. Truth set at the moment S has empty intersection with truth set at the moment T. So it's quite stronger property than the one that was required at the beginning. We have ultimately temporal intuitionistic sets, and we have initially temporal intuitionistic sets. Ultimately, temporal intuitionistic sets are those families of pairs of sets, as you can see here, that become temporal intuitionistic sets starting from some moment t, yes, such that for any t lesser than or some moment s, such that for any t greater than or equal to s, the intersection is empty. But for those earlier moments, this intersection may not be empty. So from some moment it is temporal intuitionistic set. The same for initially temporal intuitionistic sets. They are intuitionistic from the first moment to some s, and then they are intersection of the counterparts for other moments can be non-empty. Yes, this is described here in a formal manner. There's some example here. You can check that yes, indeed, this is strictly free, ultimately temporal intuitionistic set in the light of our previous definition. Consider now this family of pairs of sets. We start from 0, 2 and 0, 2, so they are identical, and of course their intersection is not empty. This is just intersection of the set with itself. Then we have the second element of our family, from 0 to 2 minus 1/2, and from 1/2 to 2. Clearly their intersection is again non-empty, but it's smaller in terms of measure, in terms of length of the interval. The same for A3, and in general you have that the left counterpart starts at 0 and leads to 2 minus this series, and while the right counterpart, the falsity counterpart, starts here, and its final point is 2, and it's open. What's the idea? As you can read here, we know that the reciprocals of powers of 2, and clearly here we have reciprocals of powers of 2. They produce a convergent series, and its sum is 1 when the first term is 1/2. Yes. In the limit, each right counterpart of an will start slightly below 1. It's here, yes, and will finish at 2, while each left counterpart will have its end slightly above 2. It would be 2 plus something, but this something, yes, as you can see here, slightly above 1, I wanted to say, of course, slightly above 1. It would be 2 minus something close to 1, so it would be something slightly more than 1. What's the result now? As you can see, there will be always some non-empty intersection of both counterparts, but this intersection can be made arbitrarily small if n is big enough. So we can say that families of this kind, they tend to become temporal intuitionistic sets in infinity. So I think it's something interesting that this should be studied in future research. This is my bibliography here for this paper, a choker about intuitionistic sets and intuitionistic points from 1996, and about intuitionistic topologies. This was presented in 2000s. An interesting paper by Chuchi about ortho pairs and intuitionistic sets and the relationship between those sets and intuitionism and free-valued logic. Atanassov on intuitionistic fuzzy temporal, as you can see, topological structures. Some paper about temporal intuitionistic fuzzy sets of second type. It is here. Quite interesting study about fundamentals of soft sets theory. So there are some questions of intersection, union, and so on. And moreover, we have neutral-sophic crisp set theory. And I think that this concept of temporal intuitionistic sets can be generalized to the idea of temporal neutral-sophic crisp sets. Thank you very much for your attention, as always.